All right, so this is going to be the recording for the Unit 4 lab. Technically, it shows up on your schedule this Friday, right? But it's not going to be due until a week from the Sunday after this. So I'm just getting the recording done. You've got a little bit of time to work with on this. One thing you do need is crushed ice. So in case you have to, use an ice tray to make some ice, you'll want to start that. But if you get to it early or before the date, you can access the lab here. Otherwise, it does show up November 6th. So if you're looking at the plan, it's 4.04 laboratory. Okay, and you can see it's not officially due until the 15th. So I'm clicking more. I'm going to go through and grab the assignment from the Dropbox area, right? So this one is a Dropbox assignment, it's not a discussion. Oh, I clicked on the wrong thing. That's why this looks weird. Let's go back to chemistry. Sorry about that. Let's think on the 4.04 laboratory and more. There we go. And again, we're going to go to the Dropbox area. And you're going to grab this Unit 4 lab report with tables. Make sure you grab the lab report with that title. I changed it from what was originally there so that you include your tables and are going to show me some work for calculations. So make sure you grab that lab report because that's what I'm going to use to grade. That's what I'm going to be expecting as far as grading goes. I'm not sure if the other lab report somewhere, but if it's anywhere else, I unfortunately can't switch it out. This is the only place where I can upload my own files. And it will be on 30 points instead of 20. So grab that table. It looks like this. Starts out with a table that's the same thing that you have in the lab manual. That way you can fill everything in, right? And then equipment-wise, you're gonna need, there's a bunch of styrofoam cups in a kit. There's a baggie that has rubber bands that you're gonna wanna put on the top cup so that when you put the bottom one on, it fits real nice and snug. And you're gonna do this twice. One you'll label 2, and then I actually already have some water in the one labeled 1, which is why I'm not going to tilt it. You're also going to want a scale. All right, so if you turn this on, you want to make sure before you put anything on top of it that it says 0, like that there. You're also going to need your thermometer, which is in this little cardboard tube. All right, and you're going to need water, preferably distilled if you have it. If you don't have distilled water, try to use purified water. Lastly, if you don't have purified water, that's fine. You can use tap water, but that can create error because there's things dissolved in it. Ideally, we want to work with pure water, if it's possible, which would be distilled water. But you're going to want your 25 milliliter measuring graduated cylinder, all right? And your lab manual. I'm going to move this out of the way for a second. You're going to open up to page 39 or the heat transfer lab. Okay, so go ahead and read through the front page, through the hypothesis area, and then we will take off with the procedure. Okay. All right, so the table that's in the lab manual is this exact same table that's in your lab report. So we will be filling that out as we go. And the beginning part, the procedure about the rubber bands. So I have my 2 cups. So I have the cup that has the lid. That's the one you want to put the rubber band on. So that's going to make it so that when you put this in, it makes an airtight seal, right? Because now it's not falling off. Even if I shake it, it's not falling off. All right. There's also, when it says about making a hole in the lid, these lids actually already have one in there that your thermometer will be able to push through in the very center. So you don't need to worry about making a hole. You might want to just kind of push it in a little bit because then it's perforated, just to make sure that when we get to the point of putting the thermometer in there, it'll go in nice and easily. All right, so that's steps 1 through 4. Then you want to measure your empty cups. All right, I already measured one, but I'm going to measure my second one, which is a little bit heavier, so make sure you measure both. They aren't necessarily the same. So mass of cup 2 empty is 17.8 grams, and then my mass of cup 1 empty was 11.5. Okay, then you're going to measure out 50 milliliters of water. The biggest graduated cylinder that you have is 25 milliliters, so you'll have to do this twice. Right, so that's why I already have some water in my cup. I did it once and then have it measured. So here's my second. So now I have a total of 50 milliliters of water in here. I'm going to put my lid on. You know what? I just realized that I did not measure my cup with the lid before. So I'm going to measure my lid. It is 6.7 grams. I'm going to add that to this. So 11.5 plus 6.7 is going to be 18.3. That way, I actually have it. Okay. Alright, so I'm going to put that lid on, and now I'm going to remass. Alright, so make sure before you mass anything you have it zeroed out. For some reason it's not zeroed out. The button all the way to the right is your 0 button. And then I'm going to put it on top with the water in there. And that's 67.1. I know my cup is blocking that from me, so you can't see that. But with the water is 67.1 grams. You actually don't need to type in the G. You can if you want to, but since it's in parentheses over here, we don't have to do that. And to calculate it, I just subtract out the mass of the empty cup to figure out what the mass of the water was. So 67.1 minus 18.3 is 48.8. So I don't have distilled water. I'm using purified water. Using pure distilled water, and if I measured exactly 50 milliliters, the mass should be 50 grams. All right. Not using true distilled water and or my measurement not being entirely 50 milliliters is probably why this isn't 50. It will not have any sort of effect on our calculations. All right, now I need to get my thermometer in to get the initial temperature. Now, keep in mind these thermometers are not instant read, which means when you put it in there, the first measurement you get is not necessarily the actual measurement, okay? And then, of course, if you're holding onto it with your fingers, hold on high so that you're not having your hand actually adjust the measurement. So what you want to do is give it a good minute or two before you take your temperature measurement, just to be sure that you're not reading the temperature too soon. All right, if you don't see it changing at all, or if you notice it changing, then you're going to wait until it stops changing to take your final measurement. So my temperature has been sitting at room temperature for a little while, or my water has been sitting at room temperature for a while, so it should be the same as the thermometer right now, and I haven't seen any changes. So I can see my little red line between the tick mark for 25 and 26. And I'm going to say it's closer to 25 to correctly estimate my last digit. I'm going to say that it's 25.2 degrees. Okay, you should be estimating to a 10th place on here. All right, so this final temperature we can't get yet. Where we are in your steps is step 8. We're at fill cup 2 with crushed ice and pour out any extra water so there's no liquid water left in the calorimeter. Find the mass of the ice and record it on the data table. All right. So it's suggested that you get approximately 50 grams. All right. If you don't get that exactly, that is okay. And I'm going to say if all three of your trials, you say you have 50 grams of ice, I'm going to say you are way too perfect. That can't be true. It's more than likely you're probably going to end up with like maybe 45, 60, something like that. So I'm going to move my cup 1 over to the side. I took my thermometer out, bringing in cup 2. And here I have a bowl of crushed ice. All right. I just had to take ice cubes and crush them. If you have an ice crusher, use that. It'll be more uniform and easier on you. So first off, I already did this, the mass of my empty calorimeter. I already recorded that. It was 17.8. So now I'm going to pop my lid off. And let's see, I'm at 11.8. So to get around 50, I'm going to shoot for 61.8. So, and I'm just going in with my hand. That way I get the actual chunks of ice instead of a bunch of the liquid. That way I won't have anything that I need to drain off. All right, so I definitely broke 60. So I'm going to put my lid back on, make sure this is taired, and get my measurement with the ice, which is 74.6 grams. I'm going to record that. And I'm going to save my calculation for the end to figure out the ice. All right, because what I want to do before this has too much of a chance to start melting, moving on to step 9, carefully add the ice from cup 2 to the water in cup 1. Stir the ice and water mixture for a minute. All right, when you do this, you're going to want to get the lid back on cup 1 as quickly as you can, so that we have as little loss of temperature from the cup as possible. So there's my ice. There's my lid back on. I'm going to throw my thermometer in there, and then I'm just going to gently shake it to stir. Don't stir with your thermometer, because the more you move it around, the more likely you might actually break it. So I'm just going to kind of sit here and stir it. I can see my temperature's dropping. And I'm looking at my computer right now. It says 147. Or sorry, 146. When it hits 147, I'll stop. And there's 147. Okay, so first thing I gotta do is measure my temperature. I'm gonna record that. It's very hard for you to see at an angle that I have, but I'm seeing my thermometer is almost just below the 1 degree mark, so I'm gonna say it's at 0.9 degrees. So that's my final temperature, 0.9. And then I need to get a mass of the cup with water and ice. So I'm going to pop out my thermometer. Take the thermometer out. I'm going to put this on the scale. And I have 123.6 grams of water and ice in the cup. And then it says that I need to pour out the water. All right, so I don't want to lose the ice when I'm doing this. I also don't want to touch it so that I melt anything. So I'm just going to, what this is called is decant, and just slowly let the water go out from the ice without losing any of the solid. And I can use the thermometer. It's not really going to change the temperature. It's not warm like my hands. I'm using the thermometer to try to hold the ice still. Keep pouring as much as possible. I don't want to lose any ice. If I end up with a little bit of water left, it's okay. That might be a source of error. I'm going to put my lid back on. That was part of my initial measurement. And I am down to 62.8 grams. All right, so that's the actual lab procedure. From here on out, it's calculations. First calculation I need to do is to get the mass of the ice that I started with, which is going to be the 74.6 minus the 17.8. So 74.6 minus 17.8. I don't need this open. It's 56.8, so 56.8 grams of ice. All right, so mass of ice remaining. So I had a cup with the ice remaining was 62.8. So I'm going to do 62.8 minus the cup, which is cup 2, so 17.8. So 62.8 minus 17.8 gives me 45.0 grams. And then the mass of the ice that melted. So I started out with 56.8 grams of ice, and in the end, I'm left with 45. So if I subtract those, I'll know what I lost due to melting. 56.8 minus 45, 11.8 grams. Okay. So the heat that is needed to melt the ice. To do this, we need to take, I'm going to try doing 2 windows up here. So to measure the heat that was required to melt the ice, we need to measure the change in heat in our calorimeter, in our system, all right? Which would be the change in our water, all right? So we had our total mass in there was water and ice. Right here, mass of cup 1 and water and ice. We had a mass of 123.6 grams. All right, then we're dealing with water and we're assuming pure water, so we're going to use that coefficient, the specific heat for water, which is, so multiplying 4.184 joules. Run out of room here. Per gram degree Celsius. All right, and then delta T is your change in temperature. It's always going to be your T final minus your T initial. So our final temperature was 0.9 degrees minus the initial temperature, which was here, beginning temperature 25.2 degrees. All right. So to calculate that out, first off, I'm going to do 0.9 minus 25.2. So that's 24.3 degrees difference in energy, or in temperature, sorry. Then I'm going to multiply by my coefficient for my specific heat for water with a 4.184, and multiply by my mass. So that means that total, we had a loss of that many joules. All right. Another way to think about this is that it took the water lost this much energy, right? Because it cooled down. So it's losing energy here. Another way you can think about it is it takes 12,566 joules to melt the ice that actually melted. All right, so for trial 1, the heat that's needed, you have to put in 12,566 joules of energy in order to melt the ice. All right, then one number that's a little bit more useful, because this is specific to the exact amount of ice that we used, or the exact amount of ice that we melted. Specifically, to melt 11.8 grams of ice, it takes this many joules of energy. Right? Something that would be more useful is if we knew how much energy it took per gram, because then no matter, say you wanted to melt 500 grams of ice, it'd be much easier to figure that out if you knew the joules per gram. So that's what this last step is. It's finding your enthalpy of fusion. To do that, you're going to take your 12,566 joules and divide by the 11.8 grams of ice that we melted. So 12,566 divided by 11.8. Equals 1,665 joules. That can't be right. Redo this.